this one out. This is going to be really fun. So this one has 2 square roots. The difference between this one and some of the other ones that had 2 square roots is this one has 2 square roots and a 4. It's going to make it a little bit trickier, but we can totally handle it. The thing that you have to realize is that we always square both sides of the equation, and you square the whole side. So if we try to square the left side with the square root of x minus 7 plus the square root of x plus 1, you cannot just square term by term. So if you FOILed it or used that special product, what would end up happening is that not all of the radicals would cancel. But that's okay. We'll just have to use a different technique, right? We probably are going to end up having to square twice, but that's okay. Totally cool. So remember on those directions they talked about isolating one of the radicals. So let's isolate one of the radicals by maybe moving the square root of x plus 1 over to the right side by subtracting the square root of x plus 1 from both sides, and we will isolate the square root of x minus 7, and on the right side we have 4 minus the square root of x plus 1. Now when we square both sides, remember we have to square the whole entire side, and so when we square this right side, we are not going to square term by term, right? We're going to have to use that special product. The left side is going to be pretty straightforward. What's the square root of x minus 7 squared? Just x minus 7, right? Now on the right side, I'm going to say it like a million times, you cannot just square term by term. You can't just square the 4 and square the square root of x plus 1. Right? We have to use our favorite product, special product here. Right? The a minus b squared is a squared minus 2ab plus b squared. Right? So our a's and b's are a little bit weird, right? Now, well, the a is not that weird. A is 4, so we'll have 4 squared minus 2 times our a, which is 4, times our b, which is the square root of x plus 1, and then plus our b squared, so that will be the square root of x plus 1 squared. Right? So if we simplify this right side, we'll end up with 16. The 2 and the 4 are friends, so we'll combine those two. We'll have 8 square root of x plus 1, and then the square root of x plus 1 squared is x plus 1. So that radical went away. The radical around the x minus 7 went away. The radical around the square root of x plus 1 squared went away. But this radical didn't go away. That does not mean we did anything wrong. This is just the technique that we need to use when we have 2 radicals and a number. What you have to do is you have to isolate one of the radicals, square both sides, and at least we've gotten rid of the radical around the x minus 7, right? And then we're going to isolate the second radical and square both sides, and we'll be able to get rid of both radicals. But it's kind of a 2 squaring process. So the next thing we probably want to do is kind of combine like terms and move some stuff over and all that kind of good stuff. Right? So the 16 plus the 1 is 17. I'm going to put maybe the x plus 17 here, and then our 8 times our square root of x plus 1. And let's see, remember we're trying to isolate this radical. So we kind of want to get rid of the x and the 17 by subtracting x and 17 from both sides of the equation. I'm just going to do it all in once, if that's cool. All right. And, oh, cool, our x's cancel. I love when that happens. All right. Minus 7 minus 17 is minus 24. Okay, and all that's left over on the right side is negative 8 square root of x plus 1. Cool. Well, we're not done, but it definitely looks a lot better. Like I said, at least we only have one more radical. We got rid of one of them, and now we're going to get rid of the other one. Now, we have a minus 8 out front. We could keep that minus 8 out front, but since there's a minus 24 on the other side, it's going to be pretty easy to divide by negative 8 and really isolate that square root. If for some reason it doesn't work out and you cannot just divide through by the number in front of the radical, that's okay too. What you'll do is when you square both sides, you'll square the square root and you also square the negative 8. But I'm going to go ahead and divide through by the negative 8 because it definitely makes it a little bit easier, makes the number smaller and stuff. And what we're left with is 3 equals the square root of x plus 1. And we're totally cool now, right? We square both sides. It's a nice, easy, straightforward one, like one of our first examples. Right? And we'll be left with, sorry about that, 9 equals x plus 1, and so x equals 8. Phew! We did it! All right, now of course we need to check to make sure that it's not an extraneous solution. So let's go back up top and make sure that 8 works. All right, so we'll plug it in. We'll have 8 minus 7 inside the radical. The x appears in 2 places, so we'll have to put the 8 in both places. X 8 plus 1. Right, does that equal 4? Let's see, we have square root 1 plus square root 9. Sweet! It's not extraneous. It totally worked. Right? So, once again, the basic technique, isolate one of your radicals, square both sides, making sure that you don't square term by term, but square it as a binomial using the fancy product. Then, it's going to get a little messy, but then you just isolate your second radical and do it all over again. Cool? I'll try another one too.